Alright, today we're going to talk about similar figures. And so similar figures, in order to be similar, corresponding angles have to be congruent and corresponding sides have to form equivalent ratios. So if I have a triangle, and let's say the sides are 8, 7, and 9, in order for a triangle to be similar, we'll call this ABC. The corresponding sides have to be equivalent. So in order to be equivalent, you can take those numbers 8, 7, and 9 and multiply it by a common ratio. So let's say I multiplied it by 4. So equivalent triangle, and it has to go in order, so I want ABC on this. So it has to stay in ABC form. So 8 times 4 is 24, or 32, sorry. Seven times 4 is 28, and 9 times 4 is 36. So equivalent triangle to ABC would be 32, 28, 36. So if you're given two triangles and you're told they are similar, then you can set up a proportion to find out the missing length on the similar triangle. So there's different ways you can set up the ratio. You can set it up as sides on one triangle, so that could be 6 to 3 equals 9 over x, or you can do similar sides on different triangles. So you could say 6 to 9, so small to big, equals 3 over x. And what you'll notice when you cross multiply, I'm doing 6 times x and 3 times 9. On the other one, I'm doing 6 times x and 3 times 9. So either way you set it up, you're going to do the same multiplication. So 9 times 3 is 27, and 6 times x is 6x. So to solve, I need to divide by 6, divide by 6. So 6 will go into 27 4 times, and 27 minus 24 is 3. So that would be 4 and 3, 6, which reduces to x equals 4.5. If you had to make it a decimal, it'd be 4 and 5/10. So now we got a couple quadrilaterals that are similar. So again, you can set up your ratio as sides on one quadrilateral. So it'd be 2 and 1/10 over 3 and 4/10 equals x over 4 and 5/10. Or you can set it up as ratios of similar sides from different quadrilaterals. So that would be 2 and 1/10 over x equals 3 and 4/10 over 4 and 5/10. Either way, you're still going to do 2 and 1/10 times 4 and 5/10 and 3 and 4/10 times x. So I'll get 3 and 4/10 x equals 2 and 1/10 times 4 and 5/10. It's going to give me 9 and 45/100. Now I'm going to divide by the 3 and 4/10. And when I divide that, I'm going to get a decimal, and I'm just going to round it. So x is going to be about 2 and 78/100. So when you get decimals like that, just round them to the nearest thousandth is fine. Alright, here's one I've seen a lot of, and that's a triangle within a triangle. So that first triangle, the small one, we have a ratio of 5 to 12 equals x is the one we're trying to find. That's on the same side as the 5, corresponding sides. Now, the bottom side of that triangle, if you look at it, that 20 only represents that length right there. So if I was to go with that length right there, this does not make a triangle. So I need to combine this length with the other length of 12 to make a triangle. So 20 plus 12 is going to give me 32. So now I have a proportion I can solve. So 12 times x is 12x equals 5 times 32 5 times 2 is 10. 5 times 3 plus 1 is 16. So I get 12x equals 160. So I'm going to divide by 12. So x is going to equal 12 goes into 160, or 16 once with 4 left over. 12 will go into 40 3 times, and it's going to be 3 repeating. So x could equal 13 and 1/3. So it's either 13 and 3 repeating or 13 and 1/3.